Hello, my name is Karsten, and this is my demo video for Lab 0 for Computer Communications with Dr. Janise McNair. I'm going to show you how I run some custom Mininet prompts and evaluate link performance and latency and those kinds of things. So the first thing I'm going to do from part 2 of the lab is set up a single topology with 5 hosts. So I'm going to do single with 5 hosts. I'm going to start that. And there we see in Wireshark all of the messages. All of this stuff I'm still not totally comfortable with how this is working. I imagine these are the switch is sending information back to the controller. I imagine that's what all of the OpenFlow protocols are, is switch to controller communication. And I guess it's telling the controller when a packet is coming in and out. But I'm still a little bit unclear on what all of this is. So from here I can run a ping from host 1 to host 4. I'm going to do 8 pings so we can look at some of the average times and how they change. So host 1 to host 4. Let this go through. So here we see the minimum time was 56 microseconds and the average time was 472 microseconds. And we also see that decreased a lot after the first couple of pings, and I believe that is because the controller puts flow entries onto the switches, which from what I understand is like a routing table sort of thing, so the switch can forward the packets much more quickly once those flow entries are installed. So that's one switch with 5 hosts. Now we're going to look at a linear topology with 5 switches. So we'll remember these numbers, average of 0.472 millisecond. So now I'm going to do a linear topology with 5 hosts. And I'm going to do the same ping, H1 ping count 8 to H4. I'll let that go through. So again, we see that the round trip ping time was a lot longer in the beginning and then got a lot shorter after the flow entries were installed. And we see here that the average ping time here was 1.79 milliseconds versus before where it was 0.472. And this makes sense because for the linear topology, the packets have to travel through 4 links to get from host 1 to host 4. But in the single topology, they only had to travel through 2 links. So it makes sense that I think it's 4 links here. It might be 5 links. Yeah, I think it's 5 links here. So that's what explains the difference in round trip times there between the 2 topologies. Now I'm going to demo the link variations. So here's the command that I'm going to run. In the walkthrough the delay was 10 milliseconds, but here we're going to make it 20. So if I do this, I can now ping host 2 from host 1. I'll just do 4 pings here. Host 2. And we'll look here. So again, the time in the beginning was a lot longer, and then the flow entries were installed, and the ping time went down to about 80 milliseconds, which makes sense because the packets have to traverse 4 links to go round trip from host 1 to host 2 and back, and each link takes 20 milliseconds, so 4 times 20 is 80 milliseconds. So now I'm finally going to demonstrate the custom topology. So here's the path to my Mininet source code. I'm running this on native Arch Linux, so I built this from source, and I'm going to run this interactively so that I can demonstrate that this topology is actually the same as a linear topology with 2 hosts and 2 switches. So I can first do the ping all to show that all of the hosts can communicate with each other. And then here I can look at the nodes. So I have controller 0, hosts 1 and 2, and then switches 3 and 4. And if I look at the links, I can see that host 1 is connected to switch 3 is connected to switch 4, and switch 4 is connected to host 2. So now I'm going to run the linear topology with only 2 hosts, and I'm going to look at the nodes. So the same set of nodes, right, with different names though. A controller, 2 hosts and 2 switches. And if I look at the links, I see that host 1 is connected to switch 1, switch 1 is connected to switch 2, and switch 2 is connected to host 2. So to me this proves that the custom topology was just a linear topology with 2 switches and 2 hosts. So hopefully this is sufficient to demonstrate my knowledge of Mininet and that I have it set up properly and know how to use it. Thanks for watching.